In this problem, we're asked to find the period and the location of all the asymptotes and sketch 2 cycles of the graph of y equal to the secant x minus pi over 2. In order to do this, we will look at its reciprocal, which is cosine. Excuse me. Which is cosine. Looking at the graph of just y equal to the cosine of x minus pi over 2, we will see that a is equal to 1, which means that our original function secant has a range from negative infinity to negative 1, or 1 to infinity. In order to find the period, we would see that b is equal to 1, therefore our period, which is given by 2 pi over b, would remain to be 2 pi. Finally, our phase shift, we can see, since our leading coefficient on x is 1, that our phase shift would be the opposite of c, or pi over 2 divided by 1, giving us our phase shift of a positive pi over 2. We are now ready to sketch our graph. If we looked at our 1 cycle interval for cosine, we would add pi over 2 to both sides, giving us 1 cycle between pi over 2 and 5 pi over 2. We are now ready to sketch our graph of the cosine of x minus pi over 2. In order to sketch 2 graphs, I made my first cycle between pi over 2 and 5 pi over 2, which is 2 pi units. Going in the negative direction, my next interval would be from pi over 2 to negative 3 pi over 2. We will first sketch cosine in our 1 cycle interval. We know that cosine takes on its maximum value of 1 at the start and stop of that interval. Minimum value halfway between at 3 pi over 2, and then finally at 3 pi over 4, finally at 2 pi over 2, which is pi, and 4 pi over 2, or 2 pi, it hits its x-intercepts. Sketching 1 cycle of the graph. We are now ready for the next cycle. We know that halfway between it's on its interval from pi over 2 to negative 3 pi over 2, it hits its minimum. Halfway between, at negative pi over 2, it hits its its minimum and its maximum. And then it will hit its x-intercepts. We now can see that the vertical asymptotes for our secant function will occur whenever time cosine of x pi over 2 has an x-intercept. Therefore, our asymptotes are at 0, pi, 2 pi, negative pi, or our asymptotes are at all multiples of pi for n being any integer. We are now ready to sketch our actual function by looking at the reciprocal. We will sketch that in red. We will see that our function would continue on in this manner.